A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Imagine you ask a friend the same question 100 times. If they're a reasonably consistent person, you probably expect the same answer, or at least a very similar one, every single time. But with AI, that is not how the world works. You can ask an LLM the same question twice and get two different answers. It is like a digital coin flip that happens millions of times a second. Today, we are diving into the heart of that chaos. We are looking at the fundamental tension between AI's probabilistic nature and our desperate engineering desire for deterministic, predictable outputs. Can we actually force these models to be consistent, or is variability just baked into the silicon?
Herman Poppleberry here, and Corn. You have hit on the trillion-dollar question for anyone actually building with this stuff. In the lab, a little bit of creativity and vibe is great. But in a production pipeline where you need a specific JSON object to trigger a bank transfer or a medical record update, vibes are a liability. We want machines that act like calculators, but we have built machines that act like jazz musicians.
Well, before we get too deep into the music, I should mention that today's episode is powered by Google Gemini 3 Flash. It is the model behind the curtain for this specific script. And speaking of prompts, Daniel sent us a great one to get us moving. He writes, AI models are probabilistic, but how close to being deterministic can we force them to be? For example, if we constrain temperature on a structured output workflow on an instructional model, how close can we get to being able to get a replicable result for a given prompt? Or is variability simply innate to the technology?
Daniel is touching on the holy grail of AI engineering, and the short answer is that while we can narrow the path, the innate variability is much deeper than most people realize. It is not just about the settings you choose in your API call, it is about the way electricity flows through a GPU and how floating point math actually works at scale.
So let's start with the basics of that narrowing the path. Most people who have tinkered with an API know about temperature. The general wisdom is, set temperature to 0 if you want the model to stop being creative, and just give you the facts. In theory, temperature 0 means greedy decoding, right? The model looks at the probability of the next token and just picks the one with the highest score. If the word they has a 60% probability, and a has a 20% probability, it picks they every single time. So why isn't that enough to make it deterministic?
Because the probabilities themselves are not static. This is the temperature 0 fallacy. We assume the model's internal math produces the exact same probability scores every time we run the same prompt. But in a modern high-scale production environment, those scores can shift. Even a tiny shift in the 10th decimal place can flip the winner of that token competition. And because LLMs are autoregressive, meaning each token chosen becomes part of the prompt for the next token, that one tiny flip at the start cascades into a completely different sentence by the end.
Wait, why would the math change? It is the same weights, the same input tokens, the same code. If I add 2 plus 2 on a calculator, it does not occasionally give me 4.000001 because it is feeling different today. What is happening inside the GPU that makes the math wiggle?
It comes down to something called floating point non-associativity. In basic math, we are taught that the order of addition does not matter. A plus B plus C is the same as C plus B plus A. But in high-performance computing on a GPU, where you are adding thousands of numbers simultaneously across parallel threads, the order actually does matter for the final rounding of those tiny decimals. Depending on which thread finishes first or how the GPU kernels are scheduled, the sequence of additions changes.
So you are saying the hardware is literally racing itself, and whoever wins the race slightly changes the rounding of the result.
Well, not exactly. I mean, that is the mechanism. It is called numerical drift. When you are doing massive matrix multiplications, these tiny rounding errors accumulate. If two tokens are neck and neck in probability, say one is 0.45678 and the other is 0.45679, a tiny change in how the GPU sum the weights can flip them. Suddenly, your deterministic model picks a different word.
That feels like a betrayal of the word computer. We think of computers as these rigid, logical boxes. But you are describing something that is almost biological in its inconsistency. Is this just an OpenAI problem, or is it universal?
It is universal to how we currently do parallel computing. There is research from late 24, specifically from the Thinking Machines lab, looking at batch invariance. In a production setting, your request is rarely processed alone. It is batched with other users' requests to save money and time. If your prompt is batched with 5 other requests in one run, but 50 requests in the next, the memory alignment on the GPU changes. The way the kernels execute those parallel sums changes. That shifts the floating point results, which shifts the probabilities, which flips the tokens.
So, my prompt's output might change just because some guy in another country decided to ask the AI for a poem at the same time mine was being processed?
Precisely. Your output is technically linked to the total workload of the server at that exact millisecond. It is what researchers call non-deterministic byproducts of optimization. If providers wanted to make it truly deterministic, they would have to disable a lot of these parallel optimizations. But doing that makes the inference 2 to 5 times slower and much more expensive. For a company like OpenAI or Google, the cost of absolute determinism is a massive hit to their profit margins and user experience.
That is wild. We are basically trading accuracy for speed, but at a level so granular most people don't even know it is happening. I remember seeing OpenAI's documentation about their seed parameter and the system fingerprint. They basically say it is best effort. It is like they're giving you a maybe button.
It is a best effort because even if they keep the seed the same, if they upgrade the hardware from an A100 to an H100, or even just update the software kernel that manages the GPU, the math changes. The system fingerprint is their way of telling you, hey, the underlying hardware or software changed, so don't expect your old seeds to work anymore.
Okay, so we have established that the hardware is working against us, but Daniel also asked about structured output workflows. This is a huge trend right now, using JSON schemas to force the AI to return data in a specific format. If we use a very rigid schema, does that act as a leash? Does it force the model back into a deterministic corner because it simply has fewer legal tokens to choose from?
It definitely helps, but it is more like a guardrail than a leash. When you use structured outputs, the system uses constrained decoding. Essentially, at each step, it masks out any tokens that would break the JSON format. If a comma is required next, it literally won't let the model pick a letter. This significantly reduces the solution space, which naturally reduces the chances for variability. If there is only one logical way to fill a JSON field, the model will likely hit it every time.
But if the field is a description or a summary, we are right back in the soup, aren't we?
We are. The structure is deterministic, but the content inside the strings is still subject to all that GPU drift we talked about. You might get the exact same JSON keys every time, but the value for summary might start with the in run 1 and this in run 2, and once that first word flips, the rest of the summary will likely diverge.
I've seen some research on this. I think it was from December 24 that looked at Mixtral and GPT models on math tasks. Even at temperature 0, the total agreement rate, meaning getting the exact same string every time, was often 0% for complex tasks. 0, as in, it never happened twice.
That study is fascinating. They found that while the answer agreement rate did it eventually pick option B in a multiple choice question remained high, the actual reasoning steps it wrote down to get there varied wildly. This creates a huge problem for vibe coding or automated agents. If the logic it uses to reach an answer changes every time, you can't reliably debug it. You might have a prompt that works perfectly for a week, and then suddenly, because the server load spikes or the model is batched differently, it takes a logical shortcut that breaks your downstream code.
It is like trying to build a skyscraper on top of a foundation made of jello. It looks solid until the temperature in the room changes. So, if we can't trust the model to be deterministic, how are people actually building reliable software with this? If I'm a developer and I need to extract data from an invoice, and I need it to be the same every time I rerun that invoice, what is the play?
You have to move the determinism downstream. This is the big shift in AI engineering right now. You stop trying to force the model to be a deterministic calculator, and you start treating it as a probabilistic engine with a deterministic postprocessor. For example, instead of just taking the LLM's word for it, you have it output its reasoning into a structured format, and then you use traditional, boring code to validate and normalize that output.
So, the LLM is the messy intern who gathers the data, but you have a very strict manager, the code who checks the work against a set of hard rules.
That is a great way to put it. Think about a fintech company processing invoices. They might use an LLM to find the total amount on a messy PDF. The LLM might return $100 or 100.00 or 100. The variability is there. But the post-processing code takes those strings, strips the symbols, converts them to a float, and ensures it matches a specific regex. The final output into the database is deterministic, even if the LLM's path to get there was slightly different each time.
That makes sense for data extraction, but what about something like code generation? If I'm using a tool like Claude Code or Gemini to build an app, and the model suddenly decides to use a different library or a different naming convention because of a GPU rounding error, that could break my entire build.
That is the vibe coding risk Daniel mentioned in his notes. This is where idempotency becomes a nightmare. In traditional software, an idempotent operation is one that can be performed multiple times without changing the result beyond the initial application. With LLMs, true idempotency is almost impossible to guarantee at the prompt level. The industry is moving toward caching as a solution. If you send the exact same prompt and the exact same settings, the API provider might just serve you the cached result from their database rather than rerunning the model. That gives the illusion of determinism.
So it is not that the model became consistent, it is just that they are showing us a recording of the first time it worked. That is clever, but it feels like a cheat. What happens when the cache expires or I change one character in the prompt?
Then the recording stops, and you are back in the jazz club hoping the drummer hits the same beat. And this leads to a second-order effect that I think is really dangerous, brittle failure modes. When you constrain a model too tightly, say with a very complex JSON schema and temperature 0, you sometimes trade variability for hallucination.
How so?
If the model is having one of those drift moments where its internal math is pushing it toward a word that isn't allowed by your schema, but it can't find a legal word that also makes sense, it might just start making things up to satisfy the structure. It will prioritize valid JSON over accurate information. You get a perfectly formatted object that is completely wrong.
It is the digital equivalent of a student who doesn't know the answer to a multiple choice question, but knows they have to bubble in something to pass the test. They'll pick C's just to move on.
And that is why the QA for probabilistic systems is so much harder than traditional software testing. In the old days, you wrote a unit test. If input is X, output must be Y. In the LLM world, your test has to be, if input is X, output must be Y. 98% of the time within a certain semantic range and follow these 12 structural rules.
We actually talked about this a bit in episode 1932, about how you can't just use standard unit tests. You have to use evils, which are basically other bigger AI models grading the smaller models' homework. It is AIs all the way down.
It really is. And for the listeners who are building things, the takeaway here is, do not trust temperature 0. It is a useful tool, but it is not a guarantee. If your business logic depends on the model being 100% consistent, you are setting yourself up for a production ghost, a bug that only appears when the server load is high or when the provider switches GPU clusters, and you'll never be able to replicate it in your local environment.
That sounds like a horror story for a developer. It worked on my machine, becomes it worked at 3 in the morning when the latency was low.
It really is. There was a case study I read about a company that was using LLMs to categorize customer support tickets. They had a prompt that was 99% accurate in testing. But when they launched, the accuracy dropped to 85%. They realized that in testing, they were sending requests one by one. In production, their system was batching them. That batching changed the floating point math just enough to flip the classification of edge case tickets.
So, what is the practical advice? If I'm Daniel, and I'm looking at these structured output workflows, how do I actually test for this? Do I just run the same prompt 100 times and see what happens?
Honestly, yes. That is called variance testing, and it should be part of every AI deployment pipeline. You take your most important prompts and you run them through a Monte Carlo style test. Run it 50 times at temperature 0. If you get 50 identical results, great. If you get 45 of one and 5 of another, you now know your confidence interval. You can build your application to handle that 5% variance.
And if you get 50 different results,
Then your prompt is too loose, or your task is too complex for the model's current reasoning capabilities. You need to break the prompt down into smaller, more deterministic steps. Instead of analyze this whole document and give me a summary, you do extract the names, now extract the dates, now extract the amounts. The smaller the task, the less room there is for the math to drift.
it is like giving the intern one task at a time instead of a whole project. They are less likely to get distracted. I want to go back to something you mentioned earlier, the jazz musician analogy. I think it was a researcher from a study on non-determinism of deterministic settings who said that asking an LLM to be deterministic is like asking a jazz musician to play the exact same solo twice. Even if they try, the physical environment, the timing, the feel of the room makes it impossible.
It's a beautiful analogy because it captures the physicality of computing. We think of code as abstract logic, but it's actually electrons moving through gates. In a GPU with 80 billion transistors, the environment is incredibly complex. The heat of the chip, the power draw, the other tasks running alongside it, all of these create a timing that is never exactly the same twice.
So, will we ever get true determinism? Or is this a permanent feature of the LLM landscape?
There are people working on deterministic kernels. These are specifically designed GPU operations that force the math to be associative, meaning the order of operations is locked in. But as I said, the speed penalty is huge. This is what's known as logit bias. You can actually tell the model, I want you to give a huge artificial boost to these specific tokens. If you're doing a sentiment analysis and you only want positive, negative, or neutral, you can bias those three words so heavily that the model literally cannot pick anything else. That is probably the closest we can get to true determinism today without writing our own GPU kernels.
That feels like the brute force method. I don't care what you think, AI, you will pick one of these three words. It's effective, but it's definitely taking the intelligence out of artificial intelligence. It's turning it back into a fancy lookup table. At that point, the speed doesn't matter as much as the accuracy.
We are learning to wrap these probabilistic engines in deterministic shells. And then you'll have logic engines that use deterministic kernels, verified hardware, and maybe even redundant checking where two different GPUs run the same math and compare notes to guarantee a result. But you're going to pay a premium for that logic engine run.
It's like the difference between buying a regular boat at a hardware store and buying a certified boat for an airplane wing. They look the same, but one has a paper trail of testing and a guarantee that it won't fail under specific conditions.
We are currently in the hardware store phase of AI. Everything is cheap, fast, and good enough for most things. But as this tech moves into critical infrastructure, medicine, law, finance, the aerospace grade, AI is going to become a huge market.
Does a smarter model have more conviction in its answers? Or does the sheer complexity just add more noise to the system? If it gave the exact same answer every time, would it start to feel more like a boring old database?
They are very sure that the quick brown fox jumps over the ends with lazy dog. On the other hand, the more layers and heads an attention mechanism has, the more parallel math is happening. More parallel math means more opportunities for those non-associative rounding errors to creep in.
So, as the brain gets bigger, the nervous system gets more complex, and therefore more prone to these tiny glitches. It's almost like a law of nature. Complexity breeds entropy. He mentioned that for OpenAI, forcing determinism would hit their profit margins. This is something we don't talk about enough, the economics of randomness.
Instead of one giant model, it's a bunch of smaller specialists. When you send a prompt, a router decides which specialist to use. That routing process is another layer of potential non-determinism. If the router is even slightly unsure which expert to use, the entire output can change.
It feels like we are chasing a ghost. Every time we find a way to nail down one part of the system, another part starts vibrating. But maybe that's the wrong way to look at it. Maybe we should embrace the variability as a feature, not a bug.
Or at least, consistency is expensive. The model is still accurate in the sense that it is following its training. It's just not replicable. And in the world of science, if it's not replicable, it's not a fact. I think that's the ultimate takeaway. We are trying to force a tool designed for meaning to act like a tool designed for math. It's like using a paintbrush to drive a nail.
Well, let's look at some practical takeaways for the folks listening who are actually staring at a terminal right now. If you are building a production system and you need consistency, what are the 3 things you should do?
First, set temperature to 0, but treat it as a strong suggestion to the model, not an absolute command. Use it in conjunction with top-pap set to 1 to limit the pool of tokens. Second, always use structured outputs, whether that is OpenAI's JSON mode or a library like Instructor or Pydantic. Forcing the structure is the most effective way to keep the model from wandering off into the woods, even if the individual words vary.
And the third,
It's the trust but verify rule. And third, move away from exact match testing. If you're testing your AI, use semantic similarity scores. Check if the meanings is the same, even if the words are slightly different. Use the AI for the fuzzy work of understanding the context, but use traditional code for the hard work of generating the final data.
tell them it's a probabilistic partner. Set the expectations early that this is a different kind of software. You need to build your systems to be variance aware.
Variance aware. I like that. It's about building resilient systems that expect a little bit of noise in the signal.
It's not that the AI is confused. It's just that the hardware is doing its best in a messy parallel world. We are essentially catching lightning in a bottle, and you can't expect the same bolt to strike the same way twice.
That is exactly it. The lightning is the intelligence, but the bottle is the GPU. And as long as we are using these massive, parallel, floating point heavy chips to run these models, that tiny wiggle in the math is going to be there. It is the ghost in the machine, and we just have to learn to live with it.
Or learn to code around it. It's a whole new paradigm of engineering. It's less like architecture and more like gardening. You can't control exactly where every leaf grows, but you can trim the hedge into the shape you want.
I love that. We're all just digital gardeners now, trying to keep the AI bushes from overgrowing the sidewalk.
Well, my shears are getting dull, so we should probably start to wind this down. This has been a fascinating deep dive into the wobble of AI. And if you want to get notified the second a new episode drops, search for My Weird Prompts on Telegram. We post every update there.
If you enjoyed this deep dive, please leave us a review on Apple Podcasts or Spotify. It really helps other curious minds find the show.
This has been My Weird Prompts. I'm Corn. Do bigger models have stronger internal logic that can override the hardware drift? Or does more complexity just mean more room for things to go sideways?
That is the frontier. Some people think scale is all you need to fix this. Others think we need a fundamental change in how chips are designed. I'm leaning toward the latter.
We'll have to see where we are by 27. But for now, we are stuck with the drift. Thanks as always to our producer, Hilbert Flumingtop, for keeping our own variability in check. And a big thanks to Modal for providing the GPU credits that power this show. We promise we aren't letting the floating point errors get too out of hand.
Mostly.
This has been My Weird Prompts. If you are enjoying the show, a quick review on your podcast app helps us reach new listeners and keeps the probabilities of our success high.
Check out the website at myweirdprompts.com for the full archive and all the technical links from today's episode.
We're also on Telegram. Just search for My Weird Prompts to get a notification the second a new episode drops.
See you next time.
Stay consistent, folks. Or try to. This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. keep weird in my